Hello, my name is Alizée Desrousseaux. I am a PhD student at the University of York, working with Brett Salak and Alistair Boxall. I am going to present a little bit of my result after conducting a systematic review on urban chemical pollution in freshwater systems. So first, why urban environments? Cities and urban environments are hotspots for chemical pollution because we use chemicals daily. We consume pharmaceutical, we use antimicrobial agent in personal care products, fertilizers in garden, waterproof chemicals in our clothes, etc. There are approximately 350,000 chemicals currently available on the global markets. Those chemicals degrade, and a part of it end up in the surrounding freshwater system via two main pathways. Either chemicals can be runoff by climatic events, such as wind or rainfall, or they can be washed down the drain. The issue here is that chemicals are not treated after runoff, and wastewater treatment plants are not 100% efficient for removing all chemicals, which lead to chemical pollution in freshwater bodies. Just a little bit of information about the motivation behind this work. There are many articles available on freshwater pollution worldwide. Researchers look at chemical concentration in different environments around the world, but the comparison of their results is usually limited to few other quantified data, which means that we are missing out on a larger spatial and temporal comparison analysis, as well as understanding the big picture of urban chemical pollution and its potential association with socioeconomics and cultural drivers. So we gathered articles looking specifically at the occurrence of chemical pollution in urban freshwater system. If an article had multiple samplings location, only the location in urban environments were kept. If the detail of location were not given and the data could not be filtered out, then the article were discarded. And all the data published in article were collected. The idea of this systematic review was to identify where in the world there has been research on urban chemical pollution, what type of chemicals were targeted, at which concentration were chemicals detected at, if this concentration were consistent across a city or a country, and last, we wanted to research the potential driving factors influencing the level of pollution. So we reviewed approximately 700 articles with 152 articles relevant for this work. At the end, the review had data for 97 cities in 42 countries. 1,100 chemicals were identified and 16,000 data points were collected. You can see here on the maps the location and the number of chemical research by city for each continent. There were more cities researched in Europe, North America, and Asia compared to Africa, South America, and Oceania, where less cities were monitored, but also less chemicals were researched. A first way to look at the data is by the distribution of concentration by countries. The different colors correspond to the different continents. The countries are sorted by the maximum concentration, and the scale is logarithmic. You can see first that the distribution of concentration for most countries is quite large, and you can also see it with the median value. The concentration above 100,000 nanograms per liter were detected in cities in China, Turkey, Morocco, and South Africa. There were only one data point above this concentration in Singapore and Brazil for the concentration of caffeine, and one in Pakistan for the pharmaceutical diclofenac. Now, the country with the lowest concentration in my database was Switzerland. An interesting fact here is that the highest concentration in Switzerland and China were from the same chemical, PFOA, a very persistent industrial chemical. Another way to look at the data is by class category. Chemicals were sorted into 16 categories. The categorization of chemicals was actually complicated because most of the chemicals belong to multiple categories. But at the end, we have those 16 categories, with pesticide and pharmaceutical being the larger class, with more than 250 chemicals. Now, if we look at the concentration of chemicals by category, you can see once again that the distribution is quite large for each of them. 14 categories out of 16 had chemical concentration above 100,000 nanogram per liter. You can also see that the distribution of chemicals is independent of the number of chemical research. The distribution of the 2021 perfluorinated compound was actually larger than the distribution of all the pesticides. Now, if we focus only on the perfluorinated compound, 21 compounds were identified in Asia and Europe only. For this category, it is very clear that the highest concentration, or the concentration above 100 nanogram per liter, were all detected in Asian cities only. If we focus on PFOA, PFOA was measured in 7 different articles. All the very high concentration were all collected from the same articles, looking at multiple contaminants across the Yellow River in China. The Yellow River goes through 3 megacities with a combined population of 21 million inhabitants. It is also a very industrial area with the largest fluorine chemical plant of the country. PFOA was also measured in another city in China, in Shenyang, but in lower concentration. The lowest concentration were detected in Zurich, in Switzerland, where the mass load of PFOA in freshwater system was considered to come from wastewater treatment plant in dry weather and from precipitation in wet weather. There are lots of ways to look at the data, but here I decided to show in more detail 3 chemicals among the most researched chemicals in my database. First carbamazepine, then sulfamethoxazole, and last DEET. First we have carbamazepine. It's an anticonvulsant and mood stabilizer used for the treatment of epilepsy and bipolar disorder and neuralgia. Only 1% of carbamazepine is extruded in fish, but since it is massively used all around the world, carbamazepine is frequently detected in freshwater system. Removal efficiency is quite low, it's around 10%, and it's a very stable chemical in the environment. On the map, you can see medium concentration across the 40 cities where it has been measured. Medium concentration ranging from 0.7 nanogram per liter to 520 nanogram per liter in Mainz in Germany. Now, if we look at the whole distribution of carbamazepine by cities, you can see that high concentration can be found across all continents. Concentration distribution can be large. You can see it for the cities of Hamilton in Canada and Rochester in the US. The maximum concentration was detected in Madrid, a concentration of approximately 60,000 nanogram per liter. This concentration was explained by the authors first by the location of the sampling, right next to the effluent of a sewage treatment plant, but also by the high number of industry, pharmaceutical companies, and hospitals in the surrounding area. It is also important to precise that Madrid River is dominated by wastewater treatment plant effluents, so that would explain the concentration quite high in the city. Another example is sulfamethoxazole. It's an antibiotic used in combination with trimethoprim. It's a cheap molecule used since the 60s all around the world. Removal of this molecule by wastewater treatment plant depends on the technology of the wastewater treatment plant, can go from 10% to 90%. And one of the application treatments of these antibiotics is for children living with or exposed to the HIV virus. You can see on the map medium concentration across cities in the world, ranging from 0.01 nanogram per liter to 2,400 in Nairobi in Kenya. Now, if we look at the full distribution by cities, you can see that the cities of Nairobi and Hanoi in Vietnam have the highest number of data points with very high concentrations. The author of the article in Nairobi explained those concentrations because of high usage of sulfamethoxazole or because of a large amount of untreated wastewater directly released into the river. In Hanoi, those concentration variations throughout the year was not fully understood by the author, but was suspected to come from change in usage during the year and change in dilution throughout the seasons. And last, DEET, it's an insect repellent used mostly in domestic products, so in spray, liquid, or lotion. The products are applied directly on skin or can be sprayed on clothes and end up in the environment when washed off. Removal efficiency can go from 5 to 90%. On the map, you have the medium concentration across 20 cities, going from 0.0 nanogram per liter to 6,800 nanogram per liter in Jakarta, in Indonesia. If we look at the distribution, DEET is detected in high concentration in tropical cities like Jakarta, Singapore, and Hanoi. High concentration in Jakarta was explained due to the massive use of DEET by the 10 million people living in Jakarta to prevent from the dengue fever from mosquito bites. The authors also mentioned that a part of the water is not treated and directly released into the environment. High concentration can also be found in North America. This could be explained by change in regulation across continents. In Europe, maximum concentration allowed in product is 50%, while it is in the US, it is 100%. To conclude, chemical pollution is not equally studied around the world. There are large regions where there is no data or very limited number of data available. Chemical concentration varies between and within cities, and there are multiple influencing factors to consider when thinking about the big picture of urban freshwater chemical pollution. The efficiency of the wastewater treatment plant, but also the population size, the regulation, the legislation, the location and characteristic of a city, the culture, the weather, the day of samplings, and all of those. The next step of this research will be to publish the result, and we are hoping to make the data easily accessible throughout our website or an interactive map or another format. We're still thinking about the best way to do it. But the idea would be that users could easily add data so that we have a clear vision of chemical pollution. We are also working on the prioritization of our chemicals in each of our cities. So here was a little bit of our result for our systematic review. I would like to thank my two supervisors, Brett Salak and Alistair Boxell, for their help and support. If you have any questions, feel free to add a comment or ask me directly during the live session. Thank you very much for your attention.